Download this code from codegive.com, link in the description below. Mastering Java Reflection, a deep dive with use cases and code examples. Java Reflection is a powerful mechanism that allows you to inspect and manipulate classes, interfaces, fields, and methods at runtime. It allows your code to examine or modify the runtime behavior of applications running in the Java Virtual Machine, JVM. This capability is extremely useful in situations where you don't know the exact types of objects you'll be working with at compile time. This comprehensive tutorial will guide you through the depths of Java Reflection, exploring its core concepts, use cases, performance considerations, and security implications, accompanied by detailed code examples. Understanding the fundamentals. At its core, reflection revolves around accessing and interacting with the java.lang.class object, which represents a Java class or interface. Here's a breakdown of the essential concepts. The java.lang.class object the entry point to reflection. You obtain a class object in various ways. Class.forName, string class name, dynamically loads a class based on its fully qualified name. This throws class not found exception if the class isn't found. MyClass.class, the most common way to get the class object for a known class. This is compile time safe. MyObject.getClass, returns the runtime class of an object. Inspecting classes. Once you have a class object, you can use its methods to gather information about the class. GetName, returns the fully qualified name of the class. GetSimpleName, returns the simple name, without package. GetPackage, returns the package object representing the class's package. GetSuperClass, returns the class object representing the superclass, or null if it's java.lang.object. GetInterfaces, returns an array of class objects representing the interfaces implemented by the class. GetFields, returns an array of field objects representing all public fields of the class, including inherited ones. GetDeclaredFields, returns an array of field objects representing all fields declared in the class, regardless of access modifiers. GetMethods, returns an array of method objects representing all public methods of the class, including inherited ones. GetDeclaredMethods, returns an array of method objects representing all methods declared in the class, regardless of access modifiers. GetConstructors, returns an array of constructor objects representing all public constructors of the class. GetDeclaredConstructors, returns an array of constructor objects representing all constructors declared in the class, regardless of access modifiers. GetAnnotations, returns an array of annotation objects representing the annotations present on the class. IsInterface, isEnum, isArray, isAnnotation, isAnonymous class, isLocal class, isMember class, methods to determine the nature of the class. Working with members, fields, methods, constructors. The field, method, and constructor classes allow you to interact with the members of a class. Field, represents a field, member variable. GetName, returns the field's name. GetType, returns the class object representing the field's type. Get, object obj, returns the value of the field for a given object. Requires setting set accessible, true, if the field is not public. Set, object obj, object value, sets the value of the field for a given object. Requires setting set accessible, true, if the field is not public. Get annotations, returns an array of annotation objects present on the field. Method, represents a method. Asterisk get name, returns the method's name. Asterisk get return type, returns the class object representing the method's return type. Asterisk get parameter types, returns an array of class objects representing the parameter types of the method. Asterisk invoke, object args, invokes the method on a given object with the provided arguments. Requires setting set accessible, true, if the method is not public. Asterisk get annotations, returns an array of annotation objects present on the method. Asterisk constructor, represents a constructor. Asterisk get parameter types, returns an array of class objects representing the parameter types of the constructor. Asterisk new instance, object, args, creates a new instance of the class using the constructor with the provided arguments. Requires setting set accessible, true, if the constructor is not public. Asterisk get annotations, returns an array of annotation objects present on the constructor. Asterisk set accessible, Boolean flag, asterisk a crucial method. It disables Java's access control checks for the reflected member, field, method, constructor. This allows you to access and manipulate private or protected members. Use with caution, it can break encapsulation and lead to unexpected behavior if misused. 2. Code examples demonstrating core concepts. Let's illustrate these concepts with some code examples. Key takeaways from the example. Asterisk dynamic class loading asterisk class.forName, allows you to load classes by name at runtime. Asterisk accessing private members asterisk set accessible, true, enables you to bypass access restrictions, but be mindful of the consequences. Asterisk exception handling asterisk reflection code can throw a variety of exceptions, so handle them appropriately. Class not found exception, no such field exception, illegal access exception, invocation target exception, instantiation exception. The invocation target exception wraps exceptions thrown by the invoked method, so you often need to use e.getCause to get to the actual problem. Asterisk object instantiation asterisk constructor.newInstance, allows you to create objects using reflection. 3. Practical use cases of Java reflection. Reflection has numerous applications. Here are some of the most common ones. 1. Frameworks and libraries asterisk. Asterisk dependency injection. Diff frameworks like Spring and Goose use reflection to instantiate and inject dependencies. They can inspect class annotations and automatically wire up objects. Asterisk object relational mapping. ORM Hibernate and other ORM frameworks use reflection to map database tables to Java objects. They inspect class structures and dynamically generate SQL queries. 2. Testing asterisk. Asterisk unit testing asterisk reflection allows you to access and test private methods and fields, which is helpful for thoroughly testing the internal logic of a class. Libraries like Mockito can use reflection to create mock objects and stub method behavior. 3. Serialization and deserialization asterisk. Asterisk libraries like Jackson and JSON use reflection to convert objects to JSON, serialization, and vice versa, deserialization. They inspect the fields of a class and map them to JSON properties. 4. Dynamic proxy creation asterisk. Asterisk you can use reflection to create dynamic proxy objects that intercept method calls. This is the foundation of AOP, aspect-oriented programming. 5. Bean manipulation asterisk. Asterisk libraries for copying properties between objects often use reflection to dynamically access fields and set their values. 6. IDEs and debuggers asterisk. Asterisk IDEs use reflection to provide features like code completion, refactoring, and debugging. Debuggers use reflection to inspect object states at runtime. 4. Performance considerations. Reflection is significantly slower than direct method calls or field access. The JVM has to perform extra checks and lookups at runtime. Caching cache the method, field, and constructor objects you obtain through reflection. Avoid repeatedly calling getDeclared method, getDeclared field, or getDeclared constructor, if you need to use the same member multiple times. Avoid excessive use. Use reflection only when necessary. If you know the types of objects at compile time, use direct method calls instead. Method handles. Java 7 Plus method handles offer a more lightweight and efficient alternative to reflection in some cases. They provide a way to represent methods as first-class objects, and they can be optimized by the JVM. Example demonstrating caching. V. Security implications. Reflection can bypass Java security mechanisms, so use it with caution, especially in environments with security restrictions, example applets, web applications. Permissions. When running in a security managed environment, your code might need specific permissions to use reflection, example java.lang.reflect permission. Untrusted code. Avoid using reflection to interact with objects from untrusted sources, as this could open security vulnerabilities. Security Manager. Java Security Manager can control which operations are allowed by reflection. 6. Best practices. Use sparingly. Don't use reflection unless it's truly necessary. Direct code is always faster and easier to understand. Cache reflected members. Cache method, field, and constructor objects to improve performance. Handle exceptions properly. Reflection code can throw a variety of exceptions, so make sure to handle them gracefully. Be aware of security implications. Understand the security risks involved in using reflection, especially in restricted environments. Consider alternatives. Explore alternatives like interfaces, abstract classes, or design patterns before resorting to reflection. Method handles can also be a good alternative in some cases. Document your code. Clearly document why you're using reflection and what it's doing. This will help other developers understand and maintain your code. Principle of least privilege. When setting set accessible, true, only do so for the specific member you need to access and reset it to false as soon as possible to minimize the potential for unintended side effects. 7. Conclusion. Java Reflection is a powerful tool that allows you to write flexible and dynamic code. However, it's also a complex mechanism that should be used with care. By understanding the fundamentals, use cases, performance considerations, and security implications, you can effectively leverage reflection to solve challenging problems while avoiding potential pitfalls. Remember to use it judiciously and always prioritize clarity, maintainability, and security in your code.